We're recording. So we're on 1.2, example 1. It says for each of the following expressions, not equations, right, factor completely into linear or irreducible prime factors. Okay, so let's just redo 1a. What's the first thing we look for? Greatest common factor, right? That's the first rule of factoring. What's the first rule of factoring? Look for the greatest common factor. Other than 1, right? 1 doesn't help. But if it was a negative in front, if that had been a negative x squared, you'd probably want to factor out the negative and change all the signs. Okay, so a trinomial, it's quadratic. It's going to factor into the product of two binomials. X squared only factors one way, x and x. So again, 10 is your target product and negative 7 is your target sum. So factors of 10, positive, that add up to negative 7, negative 5, and negative 2. Or, of course, multiplication is whatative that allows you to do that. Commutative, right? Commutative. So either one of those. Perfect. That's a real easy algebra 2 problem, right? Nothing to it. All right, letter B. What do we say about x squared plus 16? It's a sum of two squares. Does it factor? No. This one we say is prime. If it were x squared minus 16, it would be a difference of two squares, which would factor, but a sum of two squares does not unless you start talking about imaginary factors, and we're not there yet, okay? So x squared plus 16 is prime. In other words, there are no values that when you plug it in for x and add 16 give you a 0. But see, that's where we're at. Okay, so now in light of today's warm-up, this one's pretty easy. What should we do first? Put them in order, right? Descending order. So negative 4x cubed minus 4x squared plus 24x. And then we look for the greatest common factor, which is 4x would definitely work. But just to make it easier, remember, if you ever have a negative leading term, pull it out as well. It's a lot easier to factor with a positive leading coefficient. So I would go ahead and pull the negative 4x out. And remember, factoring out is dividing out, but because in the expression it has to be equivalent, so we pull it out front. And so now when we divide it out, we get negative 4x cubed divided by negative 4x, and that leaves us with what? X squared. And then the next term, negative 4x squared divided by negative 4x, leaves us with a positive x. And then the last one, a 24x divided by a negative 4x, leaves us with a negative 6, bless you. And, of course, at this point, if you don't trust your division skills or your factoring out skills, what could you mentally do with your negative 4x? You could distribute and make sure you get the exact same thing as above. You could do it very quickly in your head and maybe save yourself some grief on the back end here. Now, of course, we're not done, right? We're not done. We have a quadratic, so maybe it's prime, but maybe it also factors into linear factors. If it does, it's going to be an x and an x because we have a 1x squared. So are there factors of negative 6 that add up to positive 1, positive 3, and negative 2? So there it is, completely factored. So do we finish it off now by saying x equals 0, negative 3, and 2? No, because what did the instructions say? Solve? Right, this is an expression, not an equation. Now, if it did say to solve and it was equal to 0, most of y'all would see negative 3 and 2 are the solutions, but for some reason, a lot of people tend to overlook the fact that x is a factor and it gives you a solution of 0. But we're not doing that here. So we're done. That's part C. So now that brings us to D. Oh my goodness, we're not talking about x's and y's, we're talking about u's and v's. U cubed v minus uv cubed. That kind of sounds neat, right? U cubed v minus uv cubed. You want to try it? Saying it or factoring it? Let's try factoring it, yeah. We don't need to say that all day long. Is it written in descending order? Is it in the order we like? We have two different variables here, right? So, yeah, so it's not quite like we had before. So this is fine. We have a positive leading coefficient, so I like that at least. What's the first rule of factoring? Pull out a common factor. And what is the greatest common factor? UV. Good, very good. So a U and a V come out front. And when we divide out the UV, what are we left in the first term? U2, yeah, or U squared, the rejected band name. Minus what? v squared, right? And we're done. We do one thing, we're happy, we're done. Not even. We have a quadratic factor, maybe prime, may factor. Is that the sum of two squares? It is the difference of two squares. So you need to be able to recognize special products, and a difference of two squares is a very special product. Kind of like kaboom is a very special product, but it's used for like bathtubs and stuff. But it is a special product. It makes your bathtubs very clean. In this sense, this is a special product because it has two factors that are what? I think we mentioned it last week. It's going to factor into the product of, well, what are they? If you don't know what they're called. The difference of square, like if we had x squared minus 4, that might be a little bit easier. That would factor into what? X plus 2, x minus 2. Yeah, if you want to do the plus first, I'm fine with that. So this is very similar, right? It's going to be the square root of each of them, the magnitudes, one's plus, one's minus. So this should be u plus v and u minus v. And these are called, what you get? You remember? Conjugates. Very good. I've heard that term before. These are called conjugates of each other. So a difference of two perfect squares will always factor into the product of two what you get? Conjugates. And let's say it in reverse. The product of two conjugates always gives you a what? Difference of two perfect squares. Yeah. Very good. And those are linear because they're u to the first, v to the first. So that's it. That's the prime factorization. All right. A, B, C, D, E comes next. Step one. What? Faster. GCF, which is 2x. Notice they are written in descending order. When I get bored, sometimes I shuffle the terms around. So we're left with a 9x squared plus a 6x plus 1. And again, at this point, mentally, if nothing else, redistribute and make sure you get the same thing as above, because you could make a careless mistake in factoring out. This last one right here, I see this a lot. Guess what the most common thing students put here other than the correct one? 0. Yeah. For some reason, when something divides out, they put a 0, and all of a sudden now they have two terms instead of the original 3. So if you mentally redistribute, you can catch that mistake. All right, so now we're faced with trying to factor this quadratic trinomial, and finally, it's the non-boring variety because we have a leading coefficient that is not a 1, it's a 9. But our constant is a 1, so it still is kind of boring. Whenever you have a leading coefficient that's not a 1, you're looking for factors of both 9 and 1, the leading coefficient and the constant that combine to give you 6. So there are several ways to factor that. Anyone have a method that you've learned along the way that seems to work well for you? The box method? Like, I don't know how the box method works. It involves something like this, right? And do you split up the middle term? Okay, I got what you're doing. Mm-hmm. That means both are going to be both the bottom terms are going to be the same exact sign. And then the 6 determines what the bottom right is going to be. So if the 6 was negative, it would be a negative 3 below. Gotcha. Right. Okay, so I'm going to show you all a way to do what you're talking about. This is just how you've decided to organize it, which is great, and it works for you, right? That's awesome. You're basically splitting the middle term. You're doing your target sum, target product target product, target sum. Your target product, and you said this, is always going to be the product of your leading coefficient and your constant. So 9 times 1 is 9, right? And then you said it again, except you organized it in a box. What are some factors of 9 that add up to your target sum, which is still 6? 3 and 3, okay? So this is the same as 3 times 3, which this is 3 plus 3. Okay, so now you've got it. But what do you do with those numbers? You're going to split the middle term. So here's what happens. You bring down the 9x squared, and then the plus 1 is fine. But what you are doing is you're taking the 6x, and you're going to split it up and call it 3x plus 3x. And again, this is just one way to do it. Some people can do it just by guess and check mentally, because 1 is prime. There's only a handful of combinations that will work. Namely, what's that? Well, I haven't factored anything. Notice all I've done is I've written 6x as what? 3x plus 3x. I've just rewritten everything down. So 3x plus 3x is what? 6x. That's all I've done. Now what you've done is you've created 4 terms. And so inside there, you can associate the first 2. And because this is a plus sign here, you can put parentheses like that. Y'all have done this before. Okay, so now what happens, you got to bring down the 2x, and here's where I like to put the beefy bracket. Inside these 2 groups, you're going to pull out common factors. What is the GCF of 9x squared and 3x? 3x. So in that group, you factor out a 3x parentheses, and you're left with a 3x plus 1. Plus, there's really nothing common in the second one, so you're left with, if you want to put a 1 there, a 3x plus 1. And then you close beefy brackets. Now, if you do it this way, my brackets that I have there are required, because without them, the 2x would not be multiplied by the entire quantity. Now what you do is inside the brackets, you're going to have a binomial common factor. Okay, guaranteed. In this case, 3x plus 1, 3x plus 1. So the 2x I'm just going to rewrite. And now from each of these 2 terms, here's term number 1, here's term number 2, I'm going to factor out a quantity, 3x plus 1. And what does that leave me? When I factor out a 3x plus 1 for the first term, I'll cover it up. What am I left with? I'm left with a 3x. Let me color code it here. I'm left with a 3x. And then plus, when I factor the 3x plus 1 out of the second term, I'm left with the 1. Now, it turns out that 3x plus 1 times 3x plus 1 is, once again, as we saw earlier, the same factor, so you can write it as 3x squared. Now, that is how you can factor, yes? No, because think of this that I highlighted right here, this 3x plus 1, as being just a blob. So it's like 3x blob plus 1 times blob, and I factored out the blob right here. So I took it out. And if I cover it up right here on the board, what do you see that's left? A 3x plus 1, okay? Now, to verify, here's what else you could do. You could redistribute it back in. Take this entire quantity, 3x plus 1, and distribute it. So you get 3x plus 1 times 3x, which is what we have here. And then plus 3x plus 1 times 1 is what we have here. So we can factor out common factors that are not just numbers and not just x's, right? They can be quantities themselves. So that's one way to factor it. That seems to be kind of a method that works every time. It's called splitting the middle term, which is a variation of the box method there. You could have recognized 9x squared plus 6x plus 1 as a perfect square trinomial. You could have done that. Or you could have just kind of sampled around with factors of 9, because it was either going to be a 9 and a 1 or a 3 and a 3. But factoring like that is a pretty important thing. Splitting the middle term is a very routine thing that works every time if it's factorable. All right. Let's do this one together, at least the first couple steps, and then I'll see if you can get it on your own. What is step 1? Rearrange, organize. You have one variable, so in descending order, 8x squared minus 8x minus 6. Okay, that looks better. Step 2. GCF, which is 2. Yeah, 2. So I'm left with a 4x squared. Make sure you pull the 2 out. Minus 4x, and then minus 3. And there you go. You got a quadratic. There's a 4 instead of a 1, and now you have a negative 3. So, however you want to do it, see if you can't factor this right here. I'll give you a couple of minutes. Guess and check, trial and error, box method, split the middle term, target sum, target product. See what you come up with. And once you factor it, then kind of coil it back out and see if you do in fact get what you started with. It's a way to catch careless mistakes. And also be very aware of your notation. If you do split the middle term, your grouping symbols are important. If you're missing a parentheses on any kind of like quiz or free response, you will lose a point, even if you end up with the right answer. So it's better to have parentheses and not need them. Good, good. Than to need them and not have them. And that's why I chose to use the beefy bracket on the outside instead of the kind of wimpy parenthesis. Everybody at some point has learned a slightly different trick, gimmick, whatever, for factoring depending on which teacher you had coming up. Lots of different ways to help you do that. Some of y'all got it. That's good. Some of y'all still kind of stuck. I like the target product, target sub method. It's pretty straightforward. In this case, what is your target product? Well, negative 3 would always be your target product if the leading coefficient in front of the x squared was just a 1, because negative 3 times 1 would be negative 3. So this is really a method that you use when you have a coefficient in the front other than a 1. So it's always going to be the product of the x squared and the constant. So in this case, it would be 4 times negative 3, which is negative 12. Bless you. Now your target sum is always the linear coefficient, okay, which in this case is negative 4. So what you're doing by doing this method is instead of looking for combinations of 4 and 3 that give you a negative 4, you've got it down to a single number. You're just looking for factors of negative 12 now that add up to negative 4. And of course, what are they? Negative 6 and 2? Yeah. So if you need to write it out here, just to make sense, that's negative 6 times 2. Okay, that works. And then negative 6 plus 2. Yeah, that works. So you found them. But then the key is what do you do with the negative 6 plus 2? And as we just saw in the previous example, we're going to split this middle term. We're going to write it as negative 6x plus 2x, which, by the way, you could also write it as 2 minus 6x. It doesn't really matter. So some people are like, how do you know what order to put it in? It works either way. Okay? So bringing down the 2 now, that's important. Here's where I put, well, you don't need the brackets yet. 4x squared, and then I get minus 6x plus 2x, and then minus 3. So all I've done is I've rewritten the negative 4x like that. But here's where you would need the brackets. If you're going to factor out now, if you're going to group them, put those 2 in parentheses. And because this is a plus sign, You need to put parentheses around those as well, but you can keep the plus sign outside.
Why does the plus sign change whether or not you put the parentheses?
I'll show you the other way around. If it's a plus sign, it's like you're factoring out a -1, which doesn't matter. I'll do it a different way after this and show you this is where some students mess up. Okay, so now I have this outer bracket, so I'll put 2 beefy bracket. And in the first group that I've paired together, I pull out a common factor, which is what? 2x, right? So I get a 2x parentheses. And what do you get when you factor 2x out of here? You get 2x minus 3. Now, if you're doing something right, this binomial factor that appears should be the one that you strive for in the second one as well. And notice it is already 2x minus 3. There's really nothing to factor out. So you could just put a plus 1 if you'd like to see something there, 2x minus 3. So here's your other binomial factor. So now in the brackets, you do have 2 terms. And there is a common binomial factor of 2x minus 3. And then what are you going to be left with when you pull the 2x minus 3 out? Well, in the first term, you're left with what? 2x. And this is why it's kind of nice to put the plus 1 there. You could see a number there. So now it's plus 1. And again, from there, you could drop your beefy brackets because it's completely factored again. So that is a routine, systematic way to do it. With a little bit of practice, because the numbers are still relatively small, you might be able to figure out. You might be able to say, 4x is going to be a 2x, 2x. That's me.
At this time, please release all sophomores to the competition gym for the sophomore assembly. Thank you.
Competition gym, okay? Competition gym. I'm recording it, so if you have to go to the competition gym, I'll put it on that shared folder. So, any other sophomores? Yeah? All right. Are you going? No. No. He's a junior. Okay. You're just tired. Oh, okay. All right, let me show you the other way to do it. And the other way is going to be equivalent, but there's a little bit more to be careful about. -6 plus 2 is the same as 2 minus 6, right? Yeah? So what if, let's get rid of all this. So I have space. What if I decided to write it like that, and I now have 2 times 4x squared, and instead of -6 plus 2, I have 2x minus 6x minus 3. It should still work. Here's where you have to be careful. When you group these two together, that's no problem. But if you put, right here, if you put a parenthesis right here, and then you group one around the 3, all of a sudden it's wrong. Why? You took out the negative, essentially, from the -6x, but you did not take it out from here. So what you do is if you put a parenthesis here, you change that sign to a plus sign, and now it'll work. Or you do the following. You group the parenthesis here, and you just squeeze a little plus sign inside of it. However you want to do, so that it's still 2 terms. But when that is a negative, you have to be careful. And now let's see if we get the same thing. Inside there, I'll pull out now a 2x, and I'm left with 2x plus 1. And here you got to factor out a -3. Remember I said if it's a negative leading coefficient, you factor out the negative, and you're left with an x, or 2x, plus 1. So you're going to get the same answer, but notice the factor that you are now factoring out is the other one. But it works the same way. You factor out your 2x plus 1, and you're left with a 2x, and then a -3, and you're done. So either way, just be careful if that second one that you're splitting up is a negative. Nothing new, right? Y'all have had all this before, but it's something now that's so important that we're reteaching it. When we get to it later on, we're not going to spend a lot of time. You just have to figure out how to factor. All right, let's see if we could fly through these. 35x squared minus x minus 12. Whoa! It's written in descending order, right? Is the leading coefficient 1? Please say yes. Please say yes. No, it's not, which means it's the fun variety, right? It's the fun variety. So you can do target sum, target product. 35 times 12, big. And then we'd be looking for factors of that big that add up to -1. Too many crickets. Huh. Is there another way to do this one? Kind of, You could certainly do target sum, target product. I don't know what 35 times 12 is, though. So here's another way to do it. Guess and check. Seriously. Now, if your target sum is negative 1, you're going to want to choose factors of both 35 and 12 that are kind of near each other so that when you add and subtract them, their difference is 1. So what are some factors of 35 that are near each other? Not 35 and 1, right? 5 and 7. Okay. So it's got to be a 5x more than likely and a 7x, right? What are some other factors of 35? Is that it? 5 times 7 and then 35 times 1? So it's probably going to be this. Now, factors of 12, it's probably not going to be a 12 times 1. It could be a 6 times 2, but maybe 3 times 4. Now, if you think in 3 times 4, it's either a 3 and a 4 here or a 4 and a 3. So really, there's only a couple to try. We want a negative 1. So let's try the top row here. On the outside, you're going to get a 15, and on the inside, you're going to get a 28. 15 and 28 is not going to add or subtract to give me negative 1. So that's probably not going to be it. So let's try the 3-4 combo. On the outside, you're going to get a 20, and on the inside, you're going to get a 21. Those are how far apart? 1. So, found it. Found it. Wasn't even a needle in a haystack. It was like hay in a haystack. There's the hay. Easy to find. Or I should say not finding hay in a haystack, but it's like finding a needle in a needle stack. It's not that difficult. Now, the sign, S-I-G-N. I know that they have to be opposite signs because my constant is negative, but because my sum is also negative, the larger product has to be negative. So the larger product is 21, so it has to be a negative and a positive. And you could do your FOIL, you could first, outer, inner, last to make sure. Now those are completely factored because they're linear factors and there is no constant factor other than 1 or negative 1 that you could factor out. So there you go. So sometimes trial and error is not a bad choice either. This is how I learned to factor back in the day. There were no gimmicks like boxes and target sum. It was just like factor it. I'll be standing right here with a ruler if you get it wrong. A ruler? What, are they going to measure my mistakes? No. You know what they did? Whack! I went to a tough school. It was right across. No, it was on the hands. They wrap your knuckles. Yeah. Okay. On your mark it set, H. Whoa. What do you notice about H? How many terms? 4. There's 4 terms, and it's a cubic. Is it written in descending order? It is. That's good. That's good. Any common factors? No. So, factor it. Go. If you're going to do that, that's awesome. Just squeeze a little plus sign in there because otherwise it looks like multiplication. Good. See, I'm leaving you to your own devices, and many of y'all are doing the correct first step. If you're going to do this, squeeze a little plus sign in there. Okay. Otherwise it turns into a product. There you go. Trevor's got the plus sign. Got the plus sign. Good, good. No idea what to do. Well, let's see. Think back. If you're stuck, and I'll talk to him out loud. If you're stuck, think back to another time in this lesson where we had 4 terms. What did we do? We created 4 terms, didn't we? On example F and on example E. When we split the middle term, we created 4 terms, and what did we do? Yeah, we grouped the first 2 and we grouped the second 2. So whenever you have 4 terms, that might be a good place to start. Grouping. Factor by grouping. That's what it's called. Factor by grouping. Okay? So 4 terms, factor by grouping, doesn't always work, but if I'm giving you one at this level, it's going to be one that will work. So parentheses are on the first 2. And again, this is important. Notation-wise, you're going to lose a point. Maybe in the past you never held the standard, but it's a negative there. So if you put parentheses around like that and you don't do anything else, you'll lose a point. you need to squeeze a little plus sign in there because they're still terms. All right? So make sure you do that. Now in the first two, we'll factor out an x squared, and you're left with 3x plus 1. Now, heads up, if you do this enough, that binomial that you get right there, that binomial factor, that's going to be what you're shooting for in the next group. And it should automatically work if you factor out the GCF along with any negative. So in this case, we'll factor out not just a 2, but a negative 2. And when I factor out a negative 2, fingers crossed, I get a 3x plus 1. Yes. Now, we're not done. But what we have now is two terms. We have one term minus another term, and there is a common binomial factor. So we'll pull out the common factor of 3x plus 1, and we're left with what? X squared minus 2. Now let's talk about x squared minus 2. X squared minus 2 is not an irreducible prime factor, but it is not a difference of two perfect squares either. So you can leave it like that. It does factor. It is a difference of squares, but not a difference of two perfect squares. So it would factor into the product of two whatchages. One more time. Conjugates. So it would be the square root of x squared in the first slot, which is x and x. One of them is going to be plus. One of them is going to be minus. And then the last slot is going to be the square root of 2. What's the square root of 2? I just said it. The square root of 2. So that right there is a way to factor it. It is not an irreducible prime factor, but it doesn't look that pretty. So I'm probably not going to put that as an answer choice. But it does factor. It doesn't have to be a perfect square in order to factor it. So just be aware of that. I would probably put this as an answer choice on a test. Okay? Now, if that were x squared minus 4, of course I would factor it because it would be a perfect square. What are these called? X plus square root of 2, x minus square root of 2? Conjugates. Good. One's plus, one's minus. Letter I. Boy, oh boy, oh boy. Look at that. How many terms do we have to start with? 2. Yeah, there's 2. And notice that each term is already partially factored. Partially factored. There are two ways to go about factoring this entire thing. The first method is what I call the sledgehammer method. What do you do with a sledgehammer? You do fine woodworking with it? No, you destroy things with it, right? You just bang the heck out of something with it. If you hit this with a sledgehammer, it's the same as what I say, expanding it out. You could distribute the x squared, you could FOIL these out, and then you can combine like terms. And once you combine all your like terms, it is fully expanded. Then you can work on factoring it, right? Factor by grouping, common factor, all that stuff. But if you do that, you're going to be getting rid of something that is already built in. Some of the work is already done, right? Because it's already partially factored. Two terms and each have a partial factor. So step 1 of factoring is to never not first do what? No, the first rule of factoring. The first rule never changes. That's why we call it the first rule. GCF. Look for a GCF. I have two terms. Is there any common factor in these two terms? Yes. Good. There is. What is it? I have two x factors in the first one, but unfortunately I don't have a factor of x in the second one. So that's not going to work. I don't, do I? But I do. It's just in disguise. I know you're saying right now, where did Mr. Corpy go, right? But it's just me. See? Watch. See? Look. It's me. It's a disguise. Look at this 10x minus 4. There's a common factor at least in there, right? So if I can't pull a common factor out of both of them, maybe in each term there's a factor that I can pull out. And look at this. In that second term, if I factor the 2 out, I'm left with 5x minus 2 and then 3x squared minus 1. Now 3x squared minus 1 is a difference of two squares, but they're not perfect squares, so I'm not going to factor it. Now is it okay to put the 2 and the 5x minus 2 in front since that factor was at the back? Not just yes, but heck yeah, because of the associative and commutative properties of multiplication. Now notice what that does. If I just bring down the other factor, now I can spy in each of the two terms a common factor of what? 5x minus 2. Let's factor it out. 5x minus 2, close, and then open parenthesis. What's left in the first term? X squared. Plus, what's left in the second term? 2 times, remember these are 3 factors, so when I divide out the 5x minus 2, I'm just left with those 2 factors. So I'm left with 2 times 3x squared minus 1. Now, this is not completely factored, but notice what we did is we took advantage of the fact that it was originally partially factored. Now, instead of expanding all of it out in the beginning, I have a factor that's sitting here ready to go. I do need now to hit that with the sledgehammer, but I don't need a 10-pound sledge, maybe a little 3-pound sledge right there. Dink. Just distribute the 2. So 5x minus 2 is just kind of hanging out. He's watching. And here we go. Expand the inside. We get x squared plus, let's see, 2 times 3, that's 6x squared minus 2. Are we done? No, because what happens now in that second factor? We have like terms. So that becomes 7x squared minus 2. Now, can we factor 7x squared minus 2? Is it a difference of 2 squares? No. Is it a difference of 2 perfect squares? No. If that were like a 9x squared minus 16, it'd be good. This is not a difference of 2 perfect squares, so I would probably stop there. But just an FYI, it will factor into the product of 2 whatchagetes? Conjugates. And here's how you determine what they are. What's the square root of 7? Square root of 7. And the square root of x squared is x. So that's your first slot. Square root of 7, x outside the radical. What's the square root of 2? Square root of 2. One of them's plus, one of them's minus. It does factor like that. But that is ugly. So I probably would not have that as an answer choice. Now, what if this had been 7x squared plus 2? Would it factor? No, because then that would be a sum of 2 squares. They don't have to be perfect squares. You could take the square root of anything and get a square. Okay? So that is how you would factor that. If you were to expand it out completely, you would be possibly able to get back to here. But you're kind of undoing some of the work that's built in. So it doesn't matter what you start with. If you have multiple terms and you're trying to factor it, always do what first? Look for a GCF. Whether it's in both terms or in each term, look for something you could factor out from one of the individual factors. I think we're out of time. So tomorrow we will finish this section, which means on Wednesday, we're going to talk about 1.3, which shouldn't take too long. And then the last part of class, we'll talk about the test, which will be on Thursday. So it'll be heavy on 1.1 and 1.2, exponents, 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 factoring. The next section is just simplifying expressions, which we've already kind of done. Correct, yes. This worksheet for 1.2 is going to be due on Wednesday. So you want to make sure you're working on it. I'm going to stop right there. I'm not sure with the new schedule what's going on, so I don't know if we're going to have bells.